After we talked about the series and the parallel circuits, now we will consider circuit simplification. First, you can look at this circuit. If I ask you, what's the relationship between this 10 ohm resistor and this 10 ohm resistor? You can use the rules we talked about in the previous section. Okay, there's a loop only has those two resistors, no other things, so they are in parallel. Also, they share one node, the other node. They share two common nodes, so they are in parallel. Okay, good. Then, if I ask you, what's the relationship of this 20 ohm and this 10 ohm? Are they in series? No, because in series, you need to find a node. To connect that node, only two components, no other components, but obviously this node has this one, and also the other resistor. So they are not in series. Are they in parallel? No, they don't share two common nodes. They share one node here, no problem, but they didn't share the other node. So they are actually not in series, not in parallel. So if I ask you, okay, from terminal AB, if we look into the circuits, what is the total resistance we have? How could we do this? So let's think about the method. Step number 1. You're pretty sure those two are in parallel. So can we simplify just this section? They are in parallel. They are in parallel over here. So we just combine them first. So 10 and 10 in parallel. Remember the rule, we talked about the trick. Like if we have two same resistors, they are in parallel, the result is just the one value of the resistor divided by the number of resistors in parallel. So 10 divided by 2 equal to 5. So your circuit will be simplified to this, 20 ohm and the 5 ohm. Now what's the relationship between the 20 and 5? Obviously, they are connected in series. In series, what is the equivalent? Just add them together. It will be 25 ohm. Now let's see this circuit. This circuit has three components, 100, 200, and another 200. And they have two questions over here. They want you to find the equivalent circuits from this side. From AB, what's the equivalent? Also, second question is, from CD, look to the left. What is the equivalent? The trick over here is, for example, if you want to know from AB, look into here. You started do it backward. That means backwards. So over here, what's the relationship between those two? They are in parallel. Okay, then think about what's the result. They are in parallel, same, so result is 100 ohm. And then, so those two combined together is 100 ohm. Then the 100 and this 100 is in series. So total over here should be 200 ohm. 200 ohm. But the other question is from this side. You need to look at to the left. You still from far away go back. So actually from far away go back, you will see this resistor. One side is open to the air. And when you look from right side, you only see those two in parallel. So RCD is actually 100 ohm because those two in parallel. So now let's see another circuit. In this circuit, we have 4 components connected in, I don't know, I mean those two looks like, okay, you actually the trick, remember, is you look, you from this side look into right, you actually backward to do it. You can consider those two, okay, there's a loop only connect to those two, so they are in parallel. So how about those two? Those two obviously in series because there's one node over here, only connect to those two components, no other components connected to this node. So those two in series. Okay, so you can group them to those two in series, those two in parallel, and calculate the correspondence equivalent resistance. 200, 200, you got 100. Those two in series, add them together. When you go to here, things will be pretty simple because you have 300 and 100 connected in head to tail. One node over here only connect to those two, so they are in series. So the answer you should tell me that should be this one plus this, so 400 ohm. Now let's look at this circuit. In this circuit, we have 5 resistors, R1 through R5. And what's the relationship? When you first see this circuit, it may be a little bit hard to see. But then let's pay attention. For example, from the easy one, R2, R3, they share this node. They also share another node here. Remember we talked about if two nodes connected by a wire, we consider that is one single node. So those two resistors connect in parallel. Also look at those two. Those two, they share this node and another node here. This is a node. This is another node. So R4, R5 is actually also in parallel. So if we re-sketch the circuit, it will be easier to see. Like this, R2, R3 in parallel, R4, R5 in parallel. And then you understand that if they are in parallel, you can combine those two together. And also you can combine those two together. And their question is from the power supply's point of view, what is the total equivalent resistance? So that is also talk about what's the relationship between R1, this group, and this group. If you group them together, you will see R1 is in series with this group, also in series with this group. So what is the total resistance? That is answer. So the answer is, in series you need to addition. Parallel you use parallel. Sure, if I gave you value, then you can calculate it by using the formula of parallel. Now they add more questions here. What is the voltage of V4 over here? What is voltage? Also, what is this current I over here? So how to solve voltage across resistors R4? You should understand R4, R5 in parallel. Parallel components have same voltage. So the V4 is also across the whole thing. It's actually from here to here. Remember we talked about R1. If we call this second group and third group. So R1 and the second group and third group, they are in series. If in series, we have voltage divider. Yeah. So this group and this group, this is a combination of R2, R3, combination of R4, R5. So R1 and the two groups are connected in series. Yeah, so simplified circuits is like this. In this circuit, we can see how to find V4. We use voltage divider. Voltage divider is the correspondence resistance on top. The sum of all the resistance on bottom multiply the total voltage. Another question is, what is the current I? You know the total voltage is Vs. Total resistance is the sum of those three. So total current will be based on Ohm's law. Total voltage divided by the total resistance. So here's the answer. Yeah, this is the end of this section.